these right here, your vertical asymptotes are x equals 0, x equals -9, and x equals 9. Those are three dashed vertical lines that the graph of this function will never touch. They're going to this graph right here is going to swoop off into infinity or negative infinity anytime it gets close to one of those dashed vertical lines. Okay? Because these are the restrictions. These are the things that x cannot be in the domain, which means that forms a vertical dashed line that the graph will never touch. It will approach and get closer and closer and closer to, but it will never get there. To write our domain, that is x such that x is a real number, and also x cannot be -9, 0, or 9. You've got three restrictions, so you can just write it as a list separated by commas. Now, if you wanted to write an interval notation, how many gaps, how many u's, how many jumps do you have? Right. So our smallest value is -infinity, and we go up to where? -9.
Why -9? That's probably
because we're moving from left to right. Interval notation always starts with the smallest to the greatest. So if we move from -infinity, the first restriction we hit is -9. And we have to jump over -9, and we keep moving until we hit what? 0. And we have to jump over the 0, and we keep moving until we hit, and we have to jump over the 9, and we keep moving until infinity.
Oh, wow.
That's why set builder notation is a little more efficient than interval notation for here. Okay? Each one of these U's is a jump, a gap, an asymptote. Okay? And each one of these intervals is intervals. X can be anything in this interval, this interval, this interval, or that interval.
So do we have to write those U's?
Yeah. If you write it in interval, if you wanted to write this one in interval notation, yes. But then you'd be done. See, it's everything from -infinity on the left. Interval notation is from least to greatest. So you're moving from the smallest thing on the number line up, got to jump, got to jump, got to jump, and then once it goes off to infinity, you're done. That's the greatest thing it could be. Okay, so do this one. Find the restrictions, write the domain. Name the asymptotes.
One more thing. Before we do that one, why didn't you do anything to the numerator?
Because the numerator can be anything. There's no restrictions on the numerator. All we're finding here is the domain, and the only thing that restricts, a regular polynomial has no restrictions, so its domain is infinite, but a rational expression does have some restrictions, but the only thing that restricts it is the denominator. Okay, so we're going to do things with the numerator later for other purposes, but for finding the domain, the only thing that restricts x is problems with the denominator. That's the only thing that make a fraction undefined is the denominator. So it doesn't matter what the numerator is. I'm expecting how many restrictions? Because this is unfactored, I expect 2, but I have to factor it completely as if I'm solving it. Okay? And so I check for GCF. There isn't one. I evaluate what I have. I've got a trinomial with a equals 1. So I'm going to have my 2 binomials with naked x's and 2 negative signs. And that would give me 2 and 3. Okay? Do whatever, go off to the side and do whatever factoring work you have to do to get there. Okay? This is mixed factoring practice. So x minus 2 cannot be equal to 0. So x cannot be equal to 2. X minus 3 cannot be equal to 0. So x cannot be equal to 3. Those are my restrictions. My domain is x such that x is a real number. Also, x cannot be equal to 2 or 3. I can just separate it with a comma. Or x starts at -infinity, goes up to 2, has to make a jump. Jump. At 2, and it can continue on until 3. That looks like a very small gap between 2 and 3, but it's actually infinite. There's infinite numbers in between 2 and 3. Okay? So Then I make another jump at 3, and I continue on to infinity. And that means my vertical asymptotes.
So why did you make that parentheses so close? Did you do that intentionally?
So close?
Yeah, I understand why you're saying that there's
Mm-hmm.
It's separated by the U.
Yeah, separated by the, yeah.
Oh, okay.
Yeah, the U is a little jump. Yeah, we have to jump over the 2, we have to jump over the 3. That makes our vertical asymptotes actually x equals 2 and x equals 3. Because those are the dashed lines that are not part of the function, but they show what the function will never touch. They're actual vertical lines that the function doesn't touch. Okay, so the first half of the homework is practice on domain, evaluating functions, finding domain restrictions, finding domains. Okay? And now we're going to look at expressions. Okay? So I'll make sure and get all the examples in for you to have everything you need to practice. So are we okay? Any burning questions on this? Or ready to practice it on your own? Understand the basic principles? Okay? And you can see it comes back to our factoring skills here as well. And what we're about to do does as well.
This is still 10.1.
Yes, still 10.1. Okay. So, yes, still 10.1, and now specifically we are going to look at expressions. Rational expressions. Let me put that in, rational expressions. And we are going to be, so far we looked at how we can evaluate them, or evaluate the rational functions, or evaluate a rational expression, how we can find restrictions in domain, and now we're going to look at just specifically rational expressions, not the functions, just expressions, and how we can simplify them, multiply them, or divide them. Okay. And to do this, we use all these skills that we already know, we already have, we're just putting them in a different context. Okay. So you already know all the stuff we're about to do, it's going to look a little different at first. Now, on Monday, or Tuesday rather, next week, we're going to be adding and subtracting. Keep in mind now that the rules in general in math, across all different subjects in math, the rules for multiplying and dividing are completely different than the rules for adding and subtracting. Think rational expressions are like fractions. They're like ugly fractions. Okay? So when you add and subtract fractions, what do you have to have? Common denominators, right? But not when you multiply or divide fractions, right? Multiply and dividing fractions, you just multiply and divide, you just multiply straight across. Or if you should divide, you flip the second fraction and then you multiply straight across. Common denominators not necessary. So for today, simplifying, multiplying, and dividing rational expressions, we don't need common denominators. We're good. We're just going to see how we can cancel things out. We're going to see how we can put them in lowest terms. Okay? For Tuesday, we're going to add and subtract them, and then we're going to have common denominators. Okay? That's the messiest part. That's next week, though. For today, you have all the skills you need to do what we're about to do. So let's just look at a couple of general principles to start off, and then we'll put it into practice with actual big, ugly rational expressions. So one general principle is this. If you take anything, I'll put C over C. Okay? So that could be 8 over 8, or negative 3 over negative 3, or it could be 2x over 2x, or it could be x plus 8 over x plus 8, like a binomial over binomial. Doesn't matter. You put something over itself. What does it equal? 1. Right. Huh? So anything divided by itself, no matter what that thing is, equals 1. The other general principle that we're working with is, let's take something, anything, I'll call it A, and you multiply it times 1, and what does that equal? It equals itself. Yeah.
That's what I was trying to do.
Oh, okay, yes. So we're going to use this principle now to simplify, because the idea is that if you have anything over itself, it equals 1. And do you have to write that 1?
Yeah.
No, because not.
To cancel it?
Yeah, it depends. Yeah, I mean, if there's nothing else there, you have to write the 1. But otherwise, something times 1 just equals itself. So I don't have to write A times 1. Just like I don't have to write 1A, I can just write A. If you have a coefficient of 1, just like, for example, if you have 1x, that means 1 times x. Yeah, that just means x. You don't have to write the 1, because anything times 1, it doesn't change its identity. This is what's called the multiplicative identity.
Could you have put 1A though? Yeah, elementary.
Yeah, sure, yeah. Because that just means 1 times A, 1 times X. Anything times 1 does not change the identity. Therefore, once we have a times 1, we can just drop it. Okay, because the identity doesn't change. The additive identity is 0. Anything plus 0 doesn't change anything. Okay, but we're dealing with all we're dealing with today is all multiplication and division. And the multiplicative or division identity, you can divide anything by 1 or multiply anything by 1 and the identity doesn't change. So you can drop it. Okay? Now let's look at that in terms, more specifically in terms of polynomials. So here's our rational expression, P over Q. Okay, capital P over capital Q, a polynomial, some polynomial over some polynomial. Okay? And so let's make it a little more complex looking. Let's say we've got 2 polynomials on top that are multiplied. Okay? So P times R, that could be like a binomial, like x plus 5 times x plus 3. Okay? And on the bottom, we have 2 binomials that are multiplied. Look, there's no plus or minus here. If you put 2 letters next to each other, that means multiply. And let's say that's also multiplied times R. Okay? So what this means is P times R. So let's say you have like 2 binomials, for example. 2 polynomials, whatever they are, and on the bottom is Q times R. Okay. Now we can separate that a little bit more even, because this is all multiplication, so this is a legal move. If these were addition or subtraction signs, not legal. Okay? So this means P over Q times R over R, which is 1. This means P over Q times 1, which equals P over Q, right? And so yes, that is the mathematically, according to our rules of identity, okay, that what this means is that you see, you cancel them out, because that's what they do. This is what's called a factor of 1. If it cancels out to 1, and times 1 doesn't change anything, so you can just drop it, okay? What we're doing here is we are canceling out factors. Factors means something we're multiplying by. Factors of 1. Okay? Now, look at that phrase. Factors of 1. We cannot start canceling out until we have factors. So what do we have to do first before we cancel? We have to factor. Okay? So to simplify, multiply, and divide, we have to make sure everything is fully factored first. There's our factoring skills. Once everything is factors, anything that matches, 1 on top, 1 on bottom, cancels out. It's a factor of 1, so it cancels out. But you cannot do that until you are factored. Because then, only then can you see if you have factors of 1. Okay? Now, it's not just factors of 1 we're canceling out, though. There's one other thing we need to cancel out. Okay? Let me actually put this in terms of numbers first, so sometimes it's a little easier to see. Let's say, for example, and this is already fully factored. We're assuming it's already, so let's say you factored something completely, and you have x plus 5 over x plus 3 over, and on the bottom we'll have x plus 3 times x minus 2. Okay? So maybe you started off with a trinomial over trinomial, but you did the factoring then. And do you see any factors of 1 you can cancel out? Where is? Yeah. And it doesn't matter if it's diagonal. This is like cross-canceling when you multiply fractions. Okay? As long as it's 1 on top, 1 on the bottom. Okay? Mm-hmm. Now, it's important to see this as well, because can I not cancel out those x's?
No, because they're on top of each other.
Yes. Well, 1's on top, 1's on the bottom, so why can't I cancel them out? Isn't that a factor of 1?
Because it's a whole, it's all 1.
Yeah.
It's a what?
It either all goes or none of it goes. We're canceling out factors. We are not canceling out terms. Okay? Because I can write this, at this point, since there's 1 factor on top and 1 on the bottom, I can drop the parentheses. But that doesn't change the fact that these are terms. If they are touching a plus or a minus sign, they are terms. This is a binomial, a term plus a term minus a term. You cannot cancel out terms. Yes, it either all goes or none of it. So these are, you can cancel out factors, only cancel factors of 1, you cannot cancel terms. That would not be a fair move. Okay? So this is done. Now, if you want to leave it locked up to remind yourself of that, that's fine. There's nothing wrong with leaving those parentheses. They're not necessary, but just because you drop the parentheses does not mean you can cancel out those x's. Imagine if x was equal to 1. Let's evaluate if x equals 1.
And change it to 6.
Right, that would make 6 over what?
3.
1 minus 2.
Oh, 2, 1, I'm sorry.
Yeah, so we'd have 6 over negative 1. If x were 1, we'd have 6 over negative 1. Okay? Well, if we just cancel out those x's, would we still have 6 over negative 1?
Yeah, 5 over negative.
Changes the value.
Oh.
Okay? So terms, if it's touching a plus or a minus sign, it is a term and cannot just be canceled out. That's an illegal move. It changes the value. Okay? The mathematical rule is about factors of 1. All goes or none of it. Okay? All right, the other thing we can cancel out is, all good? Okay. All right.
So was that the answer?
Yeah, that was as far as you could go.
Okay.
Yep. All right, so if we have, let's say, x plus 2 over x plus 2. What does that equal? Right. And it's a good idea to go ahead whenever you see these and lock up any binomials you see. Okay? And to remind yourself, it all goes or nothing. So anything, no matter what that thing is, anything over itself equals 1. Now what if I had x plus 2 over 2 plus x? Lock them up, all or nothing. Do those have the same value?
Yes.
Yeah.
This multiplication can be flipped.
Yeah. Addition.
Addition.
Right. Imagine x were 1. What would I have on top?
3.
And what would I have on the bottom? 3 over 3. Okay? So order of addition doesn't matter. This is still 1. Okay? So when you've got your binomial as addition, your little linear factor is addition, it doesn't matter the order it's in, it has the same value. X plus 2 is the same thing as 2 plus x. Okay? Now, what about this? X minus 3 over x minus 3. What does that cancel out to?
1.
Yeah, it still cancels out to 1. It doesn't matter whether that's plus or minus. This is still something over itself. Okay? It cancels out to 1.
So as long as the numbers are the same.
The numbers and the signs. Yeah, these are both positive x's and both negative 3's. Those are exactly the same. It's a binomial over itself. Anything over itself cancels out to 1. Now, what if you had this? X minus 3 over 3 minus x.
The same thing?
No, it's a 3's positive.
Yeah. Let's imagine that x were 5. Here, 5 minus 3 is 2, and 5 minus 3 is 2. So 2 over 2 is 1. If x is 5, then 5 minus 3 is 2, but what is 3 minus 5? Negative 2. So we'd have 2 over negative 2, and that cancels out to negative 1. Think of it this way. Let's think of it in terms of numbers. 5, for example, and negative 5 are what's called opposites. Okay? Now, if you have 5 over 5, that equals 1. But if you have 5 over negative 5, that equals, if you have negative 5 over positive 5, that equals, yeah, it doesn't matter which one's on top, which one's on the bottom. But if you have a number over itself, it cancels out to 1. If you have a number over its opposite, it cancels out to negative 1. Okay. Well, numbers have opposites, like 5 and negative 5 are opposites. Polynomials also have opposites. Now, I'm not talking about conjugates. Conjugates are a plus b, a minus b. I'm not talking about conjugates. I'm talking about opposites. Okay? So opposites look like this. Let's just take that. Let's take the 3 minus x, and I want you to factor out a negative 1. They have no GCF, right, except for 1 or negative 1. So let's factor out a negative 1. Okay. Well, if I factor out a negative 1, What does that leave behind? Then, yeah, plus x. Okay? Now it's addition, so I'm going to turn it around. I can do x plus negative 3. And plus a negative is the same thing as, yeah. And I don't need that 1 in front, but I can't get rid of the negative sign. That's the same thing as negative x minus 3. Okay? So if I factor out a negative 1, I have the opposite. Just like 5 and negative 5 are opposite, x minus 3 and 3 minus x are opposites. Okay? Because opposites means one's this way and one has a negative in front of it. Well, one's this way and this just has a negative in front of it. But if I distribute that negative again, I get negative x plus 3, and negative x plus 3 is 3 minus x. Okay? These are not conjugates. Conjugates is a plus b, a minus b. These are what's called opposites. They're both subtraction. It's just the order is flipped. Okay? And opposites cancel out to negative 1. So if you've got, these are opposites. And again, opposites are both subtraction. So if you've got the same thing, something over itself, then that cancels out to 1. But if you've got opposites, that cancels out to negative 1. Now, all that does is flip the sign of the entire answer. So it is a legal move to cancel out opposites as long as you throw a negative sign in front of your problem. It's going to flip the sign of your final answer. Okay? So if you cancel out opposites, don't worry about doing all this. I have to factor out a negative 1 and all of that. And where do I put that negative 1? No, just cancel out your opposites. If you recognize you have opposites, which are both subtraction, just reversed order, you can cancel them out, just throw a negative sign in front of your answer. It's just going to pull a negative 1 out, which can make your whole answer negative. Okay. Good? Let's put this into practice. Okay. All right. This is where it all comes down to factoring. So 2x squared minus 6x over 2x. It also all comes down to being organized, because this can get very chaotic and messy. Your basic rules for simplifying are this. First, factor the numerator and the denominator completely. That's your job first. You're ignoring the fact that it's a rational expression. Just look at the numerator, factor it. Look at the denominator, factor it. Use all your factoring skills. Start with the GCF. Where do I start? GCF. How do I know I'm done? Everything's linear. And in between, use all the skills you need. And then finally, cancel out. Once it's fully factored, you cancel out factors of 1 and negative 1. And if you cancel out opposites, then that's canceling out a factor of negative 1. You throw a negative out front. Okay? So if you have to do any factoring, if you can do it mentally, then do it mentally. If you have to do some paper and pencil to do your factoring, go off to the side. Don't mess up your problem. It gets very chaotic and messy, and that throws people off. That throws you off. It makes it hard for me to see what your thought process is too when I grade them. So any factoring you can do mentally, do mentally. Anything you can't, use scratch paper or go off to the side. So I'm going to rewrite this fully factored. I can see first I have to ask myself GCF. Yeah. So I either go off to the side and divide that out, or I do it mentally. Do wherever you are on that. Okay? Just don't do it, if you're going to do paper, don't do it all here. So I pull out a 2, and I know that 2x actually. 2x I can see, and that's going to leave behind a single x minus 3. Now if any of the factoring, just to show you these different, working with the rational expressions, I may go a little fast on the factoring. Okay? So I'm happy to answer questions, but understand that's where your goal is to get fluent with that factoring. Okay? On the bottom, I've got a 2x. There's nothing to factor there.
So you're done.
Well, now I'm factored on factoring. Now I cancel out factors of 1. Now, can I cancel out those 2 x's?
Yes.
Those look like a single term, right? But do they have any addition? Are they added or subtracted to something? No. Here, that was a problem. I couldn't just cancel out like 6x over 2x here because that's a term on top. It's touching a minus sign. But here, this is 2x times x minus 3. Factor, factor. This binomial factored into two factors. Yeah, we had 2 terms here, but they're factored into 2 factors. These are factors. You can cancel them out now. Okay? Because they're not terms would be joined with addition and subtraction, but that's multiplication right there. Okay? So that's a factor and that's a factor, so you can cancel out factors. And you're left with, that's it. Yes. Okay. So 10 plus x over x squared minus 100.
I have a quick question.
Yes.
At the top, did you did GCF of 2x for the numerator, right?
Uh-huh.
And then the denominator stayed the same?
Because there was nothing to factor. Yeah.
Okay.
You factor everything you can, but sometimes a numerator denominator is already, there's nothing to do to it.
Because there's no other plus or minus, whatever it is.
And it's also linear. If it's
Okay.
linear, there's nothing you can do with it.
That's what I'm saying.
Yeah. So anywhere you see it, if you see it's already linear, like in this case, go ahead, and it's got a plus sign, so go ahead and just lock it up. Because if it's linear, but it's got a plus sign, you got a little binomial, that whole thing is going to go or none of it. Okay, so there's nothing to do with that, but lock it up. Okay. And if it's not linear, think, how can I factor it? Check for GCF. Nope. Difference of squares. Fully factored, I've got 1 factor on top and 2 factors on the bottom. Do I see any that match, that are factors of 1 or negative 1? Factor of?
10 plus 10.
Yeah. 10 plus x, x plus 10. Those are the same thing, factor of 1. That's not negative 1 because they're both plus. Order doesn't matter, they have the same value. Now, if you cancel out a factor of 1, you don't have to write it. You don't have to write the 1 either. Except when you cancel out and there's nothing left. Okay? You may need the 1 as a placeholder. What's left on top? Yeah, if there's nothing else there, you do have to write the 1. And on the bottom, and you can leave it locked up as x minus 10 in parentheses or not. You're asked to simplify. You'll simplify by canceling out factors of 1, but you cannot start canceling out factors of 1 until you actually have factors. Look at your numerator and denominator separately. If they're already linear, you can just go ahead and lock them up. And if they're not linear, go through your factoring steps. See, I've got an a equal 1 trinomial, no GCF. Oh, but look, perfect square, perfect square. What's my a? What's my first term unsquared?
X.
And my second term unsquared? Right. And so 5 times x, 5x, double it, 10x. Check. Perfect square trinomial. Okay. So unsquared, 5 and x, that's my perfect squares. Perfect square, unsquared is x times 5, 5x, and if it's doubled or negative doubled, you're good. So that means it factors into what? Conjugates or a binomial squared?